So here we have mean of three numbers is 3. So the sum will be 9. So what we need is greatest possible value of z. So when the sum of few numbers is fixed and we need to maximize one number, what we do is we minimize all others. Okay, so this will be very frequently used in GMAT questions. We need to minimize others, and so when we need to minimize, just see what is given about those numbers. We need to minimize x and y. So given is they're positive integers, so x minimum would be 1. And the second thing we need to check is, are x and y equal, or is it given that they need to be different? Now this inequality is given which says x is less than y, so they cannot be equal. So minimum value of y would be 2. This is equal to 9, z would be equal to 6. Ada and Paul received their scores on 3 tests. On the first test, Ada's score was 10 points higher than Paul's score. The second test, Ada's score was 4 points higher than Paul's score. Paul's average score on the 3 tests was 3 points higher than Ada's average score. Then Paul's score on the third test was how many points higher? Let's say A1, A2 plus A3. These are Ada's scores in 3 tests. So this would be average score for Ada. And let's say P1 plus P2 plus P3. These are 3 scores of Paul, and this becomes average for Paul. Given is average for Paul is 3 more than average for Ada. So what we need to do is we need to convert this difference in average to the difference in sum. If the average is 3 more, what will be the difference in sum? Now if you see, just multiply both sides by 3, what you get is Paul's sum of 3 scores must be 9 more than the sum of Ada's scores. Now in first test, Ada scored 10 more, and second test, Ada scored 4 more compared with Paul. But overall, Paul need to score 9 more in the 3 tests. So in the third test, Paul need to score 23 more. Okay, so that he scored 14 lesser in the first 2 tests. If he scores 23 more in the third test, overall he'll score 9 more. So on the third test, he needs to score 23 more. S consists of 10 consecutive odd integers. T consists of 5 consecutive even integers. So let's say T is 2, 4, 6, 8, 10. Okay, 5 consecutive even integers. Least integer in S is 7 more than the least integer in T. So if least in T is 2, least in S would be 9, then becomes 9, 11, 13, 15, 17, 19, and we don't need to go further because both S and T make arithmetic progression. Okay, and the number of terms in S is 10. So that means 5th term plus 6th term divided by 2, that means 18 would be average for S, and 6 is average for T. So the difference between them is 12. That's your answer. It's a question of weighted average. The two things, product P and product Q. Price of P is 20, price of Q is 17. Okay, so if P is equal to Q, the number of this product P is equal to number of this product Q, and the overall average price would be the midpoint, which is nothing but 18.5. Okay, so we don't need to do any calculations here, we'll see. So most of the GMAT questions on weighted average are like that. So what we have is, last year the manufacturer sold twice as many units of Q as P. So now number of units of Q is more than number of units of P. That means the final average will shift towards 17. That means it will be less than 18.5. The only option is 18. Okay, so in most of the GMAT questions of weighted average will not be required to do the final calculations. The options will be arranged in such a way if it is a PS question. And let's see some DS questions as well. Employees are either managers or directors. So managers on one side, directors is the other thing. We're talking about average salary, so it could be anything: average salary, average score, average price. So these are average salaries for managers and directors, and let's say average salary overall, okay, in the entire company. First statement tells me average salary for managers is 5,000 less than total average salary. So difference of these two numbers is 5,000 from first statement. This is not sufficient. Second statement says difference between directors and overall average salary is 15,000. This is second statement. This alone is not sufficient. If we combine the two, we have these two numbers, these two differences. That's what we need to find the ratio of number of managers to number of directors. And if we see, it will be 1:3. So C would be our answer here. Again, weighted average, X, Y. What we need is, does X have more members than committee Y? So first statement tells me average age in X is 25.7, average age in Y is 29.3. Not sufficient, this alone. Second statement says overall average is 26.6. This alone is not sufficient. We combine the two. Now we can figure out that this average is closer to X. Okay, and we don't need to check whether it is closer to X or not. We'll get to know whether it is closer to X or not. So combination would be sufficient. C is your answer. Median. Now average of 3 houses is 120. So sum would be 360. We need to maintain the total sum as 360. Question is, what is the median price of the 3 houses? What is the median of the 3 values? First statement tells me one of the values is 110. So 110 being one value, we need to maintain the sum as 360. Now if you see, 120 is the median here. We can also have a situation like this. Sum is 360 and the median here is 110. So this is not sufficient. We can have different values of the median. Second statement tells me one value is 120. Now if one value is 120, the sum of other two values must be 240, so that the total sum is 360. Now that if the other two values are equal, it will be 120 each and the median will be 120. If they are not equal, like one value is 110, another is 130, 120, one value is fixed. Now if we arrange them, so the smaller value will come to the left of 120 and the bigger value will be to the right of 120. In this case as well, 120 is the middle term. So this will remain the median always in this case. So this is sufficient. B is your answer. Four numbers are there: 1, 5, 6, 7. Their sum is 19. And there are two more numbers, x plus y. This would be your mean. Okay, sum of all the terms upon number of terms. Now what we need to check is the mean greater than the median? That's what we're checking. First statement, x plus y is equal to 7. Now because of this, the total sum becomes 26, so the mean becomes 4.3. Okay, so mean gets fixed. Now we need to see whether the median will be bigger than this or smaller than this. Now x and y are positive integers, so we cannot take 0 negative as values. So the only cases we have for them is these. These are the only three combinations we can have for x and y. In this case, the arranged set of numbers would be, okay, 6 terms, so the average of middle two terms, median is 5.5, greater than the mean. In this case, this will be the arranged set, median is average of middle two, 5, still greater than mean. So in this case it will be 1, 3, 4, 5, 6, 7. Median is 4.5, still greater than the mean. So in all possibilities, median will be greater than the mean here. This is sufficient. C would be the answer. Sorry, this is sufficient. Let's check the second statement. Second statement says x minus y is equal to 3. Now here, in this case, it could be 5 minus 2 also equal to 3. 5 and 2 are the two numbers. Now if you see, we've already checked that case. In that case, median was greater than mean. Now if you see another case, another scenario in which x and y are really large numbers, like 500 minus 497. Okay, because the difference is 3, there is no cap on the values x and y can take. In this case, the set would be 1, 5, 6, 7, 497, then 500. Median would be a small number, but the average would be a big number, mean would be a big number, because the sum would be a big number. So in this case, mean would be bigger than the median. So one case where median is bigger, another case where mean is bigger, not sufficient. A will be our answer. So what is the median number of employees assigned per project for the projects at company Z? Now, let's say there are 100 projects. Okay, and we arrange them in terms of number of employees they have. Okay, so because there are 100 projects, median will be nothing but 50th term plus 51st term divided by 2, average of the two middle terms. So we just need to figure this out. First statement, 25% of the projects at company Z have 4 or more employees assigned to each project. So out of total 100 projects, okay, any project having 4 employees will be part of these 25. Any project having 5 employees will be part of these 25 projects. Every project that has 1,000 employees will also be part of this, because anything more than 4 will be part of this. Any project which has 1 million employees will also be part of it. So these 25 companies will be to the extreme right, these 25 projects, because any big number will be part of these 25 projects only. There won't be any project which will be to the right of these 25. Okay, because you name any bigger number, it will be part of these 25. So, but we don't know what happens to the remaining 75. I mean, we don't know what is 50th and 51st number. So this is not sufficient. Second, 35% of the projects of the company Z have 2 or fewer employees. So if we have 2 employees, it will be part of this. If we have 1 employee, it will be part of these 35 projects. If we have 0 employees, this again will be part of these 35 projects. So these 35, in that ascending order of the number of employees, will be the first 35. There can't be anything to the left of them. Okay, so even if something has 0 employees, it will still be part of these 35 projects. Again, what happens to the remaining 65, we don't know. I mean, we don't know what is 50th and 51st, so this alone is not sufficient. Combine the two. First 35 has maximum 2, less than or equal to 2. So if something has 2 employees, it will be part of this group. The last 25 projects, some project has 4 employees, it will be part of this. What is between, the middle 40? Exactly 3. Okay, so those projects will have exactly 3 employees each. So 50th and 51st will be part of this. So those two terms would be 3 and the median would be 3. C is your answer. Q is an odd number and the median of Q consecutive integers is 120. So odd number, so let's say Q is equal to 3. So there are 3 consecutive integers. So 120 is the middle term. So 119, 120, 121. These are 3 terms of the set. Now, which is the largest of these integers? Now, the largest here in this example that we've taken is 121. So if Q is equal to 3, the largest number should come out to be 121. So in the options, we'll see by putting 3, Q as 3, which value will be 121, and it will be A. Q minus 1 by 2 plus 120. So that is nothing but, this is the only option that will give you 121. That's your answer. So take any convenient odd number, which is 3, let's say, the easiest of the lot, and so that is the number of terms here. So it becomes super easy. Standard deviation can be practically seen as average deviation from the mean. Okay, this is not to calculate standard deviation. Okay, if you calculate it mathematically, it will be a wrong thing, but it is good to compare the standard deviation. No question in GMAT will ask you to calculate standard deviation. There could be a lot of questions which will ask you to compare the standard deviation. Now, you can find mean, okay, and you can find deviations of each term from the mean. What I'll do is I'll restrict myself to these two companies, company B and company E, because their deviations is much more compared with other 3. So you can do yourself, you can do the calculations yourself, but I'll restrict myself to this thing. Now in B, 10, 30, 30, 10. Okay, so the sum would be 80 and the mean would be 80 by 4, 20. Now difference of each term from the mean. First term is 10 away from mean, second is 10 away, third is 10 away, fourth is 10 away. So sum of deviations is 40. So the mean deviation would be 10 here, kind of. E, 50, 60, 60, 70. So here the mean is 60. Okay, and deviations of each term from the mean would be, so first term is 10 away from mean, second is 0 away, third is 0 away, and fourth is 10 away. So the total deviation would be 20. So the mean deviation is smaller. So B has a bigger deviation. B standard deviation will be bigger. So we don't need to calculate standard deviation by the method that you must have studied in school. That's the whole point here. We need to see how far away are the terms from each other. Okay, so standard deviation tells me that thing. So when we need to compare, we just need to see individual deviations from the mean. That'll be good enough. In this question, we need to see that standard deviation is never negative. Okay, it's distance from mean. Distance can never be negative, right? So the negative options are already out, and standard deviation is 0 only if all the terms are same. So now if you see all the terms are not same, 0 cannot be the answer even. So E, none of them is the answer. Now here what we are testing is let's say A1, A2, A3, A4, A5, they have a certain standard deviation D. Okay, there's a certain number of terms in a set. It could be 4, 5, 10, anything. Their standard deviation is D. Now if we add something to all the terms, or if we subtract something to all the terms, standard deviation will remain same, it will remain unchanged. And if we multiply all the terms or divide all the terms by same number, the standard deviation will get multiplied or divided, depending upon whether the number is getting multiplied or dividing, by mod of that number. That's how standard deviation changes. So set x is derived by reducing each term by 50. So every term is getting reduced by 50. So for x, standard deviation will remain same. For y, each term is multiplied by 1.5. So the standard deviation will get multiplied by 1.5. And for z, each term is divided by -4, so the standard deviation will get divided by mod of -4, which is standard deviation by 4. So y would be largest, z would be smallest, x would be in between. D option. This is also a similar question. Teacher adjusted the student's test score using the formula y is equal to 0.8x plus 20, where x is the student's original score and y is the student's adjusted score. If the standard deviation of the original test is 20, so every term is getting multiplied by 0.8 and then 20 is getting added. Now we have seen if we add or subtract something from all the terms, it doesn't have any effect on the standard deviation. But if we multiply or divide each term by something, which is 0.8 here, standard deviation will get multiplied by 0.8. So if 20 is the original standard deviation, it will get multiplied by 0.8, it will become 16. So there's a list of 100 data points and average is 6, standard deviation is D, where D is positive. Okay, so it's not 0, so what it means is all the terms are not same. Which of the following pairs of data when added to the list must result in a list of 102 data with standard deviation less than D? So this is again very frequently checked in GMAT. So let's say x1, x2, x3, x4, these are 4 terms. Okay, so instead of 100, let's say there are 4 terms. So standard deviation is given by D1, D2, D3, D4. These are deviations of each term from the mean. So for all practical purposes, standard deviation is average of all deviations. So this is your standard deviation. Now if we add one extra term, if we introduce one more term, let's say which is x5. So what will happen is we'll have 5 in the denominator because there'll be 5 terms now, and on the numerator we'll have one more deviation, d5. Okay, now if x5, the new term, is equal to the existing mean, okay, then the new distance d5 will be equal to 0. That means same numerator means whatever it was earlier divided by bigger denominator, because the denominator will go up by 1 because that is number of terms. So we'll have smaller standard deviation. So that is very frequently checked in GMAT. If the new term is equal to the mean, the standard deviation goes down. So be it 1 term, 2 terms, n number of terms that we are adding, they must be equal to the mean and the standard deviation goes down. That's what is checked. So range is largest minus smallest number. Set A consists of 8 distinct prime numbers. So when it comes to prime numbers, 2 is the only even prime numbers. Rest all prime numbers are odd. So x is equal to range and y is equal to median. Is range into median even? That's what we are checking. First statement, smallest integer is 5. So smallest number is 5, which is odd. The range is largest minus smallest. Largest number has to be odd only, because all are distinct prime numbers. So largest number cannot be 2. And smallest, it says, is also odd. So odd minus odd is even. So range into median, range is even. Even into any integer will be even. So this is sufficient. Second says largest is 101. So largest minus smallest. Largest is odd. So smallest can be 2 also, prime number, which will be odd minus even, odd. And smallest can be 5 also, any odd prime number. So in that case the range would be even. So range could be odd or even. So this is not sufficient. The product could be odd or even, not like in first case where range is always even, so the product always become even. So A is your answer. "15 different integers." That's very important. If somebody, many people miss this word different and they get the wrong answer. Has a range of 25 and the median is 25. So if you arrange 15 numbers in ascending order, the 8th term, the middle term, is 25. Median is 25. Now all numbers are different. Now this is the smallest number, let's say. My concern is, what is the maximum value of the smallest number here? Let's see. So if we reduce, from the median to the smallest number, it will be a reducing set. So if we reduce each number by 1, so it will become, smallest comes out to be 18. Now all are integers. So the numbers cannot be 24.5 or 23.5. They have to be integers. So the minimum we can reduce is 1 from each term to get the previous term. So in that case, 18 is the maximum possible value of the smallest number. And range is given as largest minus smallest, which is 25. So largest is nothing but 25 plus smallest. So when smallest becomes maximum, the largest will become maximum in this case, right? Because 25 is fixed, the only variable is smallest number, s, and that maximum is 18. So maximum value of the largest number will be 43.